Now, do the same thing, just with slightly different transformations. The basic graph, 1 squared 1, 2 squared is 4, 3 squared is 9. Sorry, we didn't talk about what we could conclude. So, let's call it ax squared, this number out in front. If a is bigger than 1, it's a vertical stretch. It multiplies every change. What I mean by it multiplies every change is that we took 1 times 3 is 3, so we actually went up 3 on this graph. And then if a is less than 1, it's a vertical shrink. Okay, so y equals x squared. Now, this minus 5, to get to the same spot where y was 0 before, I have to plug in 5, because 5 minus 5 is 0. So this 5 minus 5, I have to plug in a positive 5, and then I get 0. If I plug in 6, I get to the same spot I was here. And so this is the exact same shape, just shifted over to the right 5. So it seems weird because we're in the exact opposite direction that our brain thinks. When we see a minus 5, our brain has sort of been trained to do, oh, it's got to be left, because all the negative numbers are to the left, or when we subtract, we go left on the number line. But our brain would be wrong. Because logically, if you plug in a positive 5, you get 0, and 0 squared is 0. And so it actually moves it to the right, opposite. In the same way, this plus 2 actually moves it to the left, because if you plug in a negative 2, you get 0. So when it's inside with the x like that, it's actually and notice how I'm still doing the exact same shape that we talked about, that basic shape. Left and right 1, 1 squared is 1. Left and right 2, 2 squared is 4. So from the vertex, I'm going all those same relative positions. 1 squared is 1, 2 to the right, 2 squared is 4. And so what can we conclude? If it's x plus or minus something squared, and I'm going to say h because that's what we're going to use. If it's x plus h, this moves it left and right. And it moves it opposite of how we think. So this is C. It moves it opposite of what we think. The minus 5 shifted it to the right 5, plus 2 shifted it to the left 2. Let's do the same thing. 1 squared, 2 squared, 2, 3, 4. 3 squared is 9. Alright. So, x squared, same thing still. X squared minus 3. Imagine the 3 wasn't there. It'd look the same. Imagine you subtract 3 from everything. Well, it moves it 3 down. And so relative to this, 1 squared is 1, 2 squared is 4. And then 3 down from where that was, or you could think 1, 2, 3 and up 9. So that moved it down 3. Now let's involve everything we've done to sort of talk about the patterns we've done. Now this minus specifically flips. So it opens down rather than up. This 2 is a vertical stretch. That's what we talked about on the last page. Vertical stretch. This plus 3 is what we talked about up here. Plus 2 moved it opposite of what we thought to the left 2, so this plus 3 is going to move it opposite of what we think. Now this minus 5 is with the y. And so this is different from the x squared minus 3 because the minus 3 was outside of the squared. It was not affecting the x. It was affecting the y. And so if the minus 3 is not on the side with the y, it does exactly what we thought it would. But if we had put it on that side, y plus 3 equals x squared, we'd have to plug in a negative 3 for y to be at the same spot. And so it's opposite if it's with the right variable. So this minus 5, if you want to, you could change this so that it looked like this. Y equals negative 2 x plus 3 squared minus 5. And so this minus 5 actually moves it down 5, just like the minus 3 moved it down 5. Sorry, plus 5 moves it up 5 because we have to add it to the other side. And so we've moved left 3, flip-flop, so 1, 2, 3, and 1, 2, 3, 4, 5. Okay, so stick with me. This is my vertex. I've gone left 3 and up 5, so we've already taken care of the 3 and the 5. Now we're going to open down because of the negative. And so left and right 1, 1 squared is 1, except the 2 is there. So we're going to go down twice as far. Left and right 2, 2 squared is 1, 2, 3, 4. Double it, 5, 6, 7, 8. And you can reflect it. And so that's as far as we're going to take it because doubling 9 would mean 18. So there's a lot of stuff going on there, but if you could follow, we went left 3, up 5. We flipped it upside down because of the negative. And then we doubled all the changes. So 1 squared was 1, but we doubled it to make it 2. 2 squared from the vertex is 4, but we doubled it to go down 8. And so there you have it, the basics. So if it's not with x squared, if it was x squared minus k, or plus k is actually what we say, plus or minus, moves it moves how we think, up and down. Alright, there you have it. We're going to deal a little more intense with specific examples in the next one.